In this video, I'm going to go over the Day 2 remote plan for AP Physics 1. So let's go ahead and get into this. So we're just solving equations again. So here you go. We're solving for delta x, and that means that we need to move 1/2 k over to the other side. That'll be our first move. And divide that by 1/2 k, and that'll cancel, so all that cancels out, and that will leave us with 2 delta, because remember we're dividing by 1/2, so that's the same as multiplying by the reciprocal, so it's going to be 2 delta us over k. And then that equals delta x squared. And they've got it in parentheses there. That's fair to write it in parentheses here as well. So we're going to square root both sides, and that will give us our answer. Okay. All right. Going out of order, but it still makes sense to do it this way. Let's look at this one. So multiply both sides by delta t. And that's it. W equals average power times delta t. That was easy. Physics can be hard, but it doesn't always have to be hard. All right. Let's look at this one, solving for M2 in the gravitational potential energy equation here. So what we're going to do is we are going to move G, M1, and R over to the other side of the equation. So got to multiply by R and divide by G and M1. And why not even throw the negative sign in? We'll go ahead and move that negative over to the other side too. So this side will also be multiplied by negative R over G M1. And that's it. Cool. M2 equals negative UG times R over G M1. It would also be correct if you wrote it like R times UG, like the order doesn't matter with multiplication. So there you go. So that is the solution to that one. All right, so we're ignoring all this funsies here, and no, okay, another pretty straightforward one. So we are going to divide by f. Why did I write a p? Divide by f cosine of theta. I feel like I did this yesterday. Maybe it was something similar. Anyways, f cosine theta, and yeah, that's it. Okay, v equals instantaneous power divided by f cosine of theta. Oh, I forgot the... There you go. All right. The gravitational potential energy formula. Somebody's triggered by that. Let me... oh, no, it lost the... There we go. Okay, somebody will be triggered if I don't keep the color scheme. All right, let's proceed on here. So we're solving for delta y. We're just going to divide both sides by mg to move the mg over to the other side, and that'll leave us with delta y. So that one was also super easy. That g's doesn't really... Oh my gosh, all that went away. I was using the undo command on the keyboard, and that made a lot of things go away. delta y. Yeah, there you go. Okay. All right. Another easy one. Just divide by mass, and that will isolate v. So that will give us m equals p. And if you want to bring the arrows along, you can. What am I writing here? Oh my gosh. Let's try again. P divided by m equals v. You want to bring the arrows along, you can. You don't have to. Okay, and circle that. Indicate it's the answer. That's great. All right, and we'll do the second page here. Impulse momentum theorem. Nice. Okay, so the first thing that I know... Really? Yep, really. It's the same. This will look really familiar in just a moment. Okay, cool. So the first thing that I notice about this particular equation is that the t here and the t here will cancel each other out. You just think about, hey, if I multiply both sides by t, oh wow, the t's gone on both sides. So that leaves us with really the same equation as the last one, which we just divide both sides by m and we will be done. Okay, so just like the last go around, delta p divided by m equals delta v. That doesn't look like a v, does it? It's fine. Oh, yeah, I got my color scheme all messed up again. Oh well. We'll just go with that. Okay, solving for delta t, divide both sides by f. I'm just going to scribble out the average there and not worry about that. All right, and so you're going to end up with j, which is impulse. We'll learn about that later. Divided by force, which is a vector quantity we are aware of. And that equals delta t. Okay. And again, if you don't bring the arrows along, that's fine. I'm not stressing about that. All right. And another... This isn't going to be bad either. All right, so mass appears on both sides. So we're just going to say, hey, if we divide both sides by m, m's going to cancel out on both sides. So what do we need to do here? We need to multiply by delta t to move the delta t over to the other side. And yeah, that's pretty much it. Delta v a delta t. And that should be reminiscent of a kinematics equation that we learned a long time ago. All right, and last one for today. This video is going to be slightly more than half the length of the one yesterday, so not taking nearly as long to get through all this. Yeah, divide both sides by force. And that's it. Delta t equals delta p over force. And if you're thinking about what does this mean, if you're doing math with these, they probably need to be in the same direction. And if they're not, you're going to have to do vector things with them, vector addition or you know, trigonometry and all that fun stuff. So there you go, and I'll circle my answers, and that looks good. Hope that was helpful, and thanks for watching if you stayed all the way to the end.